Good evening, juniors. This is take 6, and we are talking tonight about measurements. And measurements are really important in science because they help us understand the relationship between variables. And so without discussing any more, let's look at our goals for tonight. And our goals are, and feel free to pause this at any time, but we just want to understand the difference between accuracy and precision. And we want to be able to express numbers in scientific notation and calculate the degree of error in a measurement, as well as identify significant digits and apply these to calculations. So let's take a look on the board, and we're going to zoom in right there. And in your notes I would include this under letter A, comparing precision and accuracy. And I kind of drew a bullseye there because I would like us to get a picture of what the difference is between these two terms. When I say a measurement or a group of measurements are precise, I mean they're repeatable. If you look on the board at the green measurements, those are not near the bullseye necessarily. However, they are very close together, and so those would be precise measurements. If we look at the measurement in red, that measurement is very near the target measurement, and so that is a very accurate excuse me, a very accurate measurement because it's near the accepted value. If I look at the measurements in black, those are very near the target area, and there's several of them near the target area, and so we say not only are those precise measurements because they're very similar measurements, but they're also accurate. A good example of something that is accurate and precise would be like stepping on a bathroom scale. Let's say that you weighed 120 pounds, and when you step on the bathroom scale, it says you weigh 125 pounds. Oh my gosh, you get off right away. And then you step on it again, and this time it says you weigh 125.1. Well, that's not right. And so you try it again, and it says 124.9. Well, all of those measurements are very close together. So we would say that your scale is precise. However, it's not very accurate because you only weigh 120 pounds. I would like you to pause the video, and if you would add a set of measurements to your targets in your bullseye target in your notes, and what would measurements look like that were neither precise nor accurate? And then when you are ready to go on, we'll get this going again, and now we're going to talk about scientific notation. We use scientific notation so we can express very large numbers in a short amount of space, and also very small numbers in a very simple format. And so if we look up on the board, scientific notation, we could see how we have several measurements up here, and they are measurements because not only do they have numbers, but they also have units. We're talking about mass in grams. And I'm going to zoom in here on that board so you can see that a little bit better. We can see the exponents there. All right. If we look at this measurement, here we have it in standard form, and here the measurement is written in scientific notation. And notice in scientific notation there are really three parts. There is the coefficient, and we always want the coefficient to be a number between 1 and 9.9. So we need a single digit here, and then we can have decimal places in our coefficient. And then we have times a base 10 raised to a power or an exponent. And this 4 indicates the number of places we have moved the decimal point. For example, in this case, 32,000, to write that in scientific notation, I moved the decimal point 1, 2, 3, 4 places to get the coefficient 3.2. So its scientific notation is 3.2 times 10 to the 4th. We could also use scientific notation to write very small numbers.
If we look at our second example, we have a very small number. This is 32, let's see, tens, or tenths, 100,000, 10,000, 100,000. So this scale measured to the nearest 100,000th of a gram, which is a very, very accurate scale. If I want to write this number in scientific notation, I'm going to write the coefficient in scientific notation, which is a number between 1 and 9.9. So how many times did I move my decimal place? Well, this time I moved my decimal to the right. 1, 2, 3, 4 places. So my exponent in my scientific notation, notice this time there's a negative sign in front of the 4. So it is 3.2 times 10 to the negative 4th, indicating that this is a very, very small number. Now what I would like you to do is to write this number, 6,020,000, in scientific notation. Go ahead and pause the video and do that at this time. If you would like to look more at scientific notation, you can look in your appendix in your textbook. It's Appendix C, section R56, and there are more examples of writing numbers both in standard form and in scientific notation. We are going to pause now, and actually I'm going to ask you to watch the next video, and the next video is going to be on significant digits.